How can we tell? How do we know what a skull would have looked like? How do we know what a skull would have looked like in real life? The average human can tell the difference between the skulls of a lion, a gorilla, and a human. They can do this by looking at the shape of the skulls and comparing them to their living counterparts. They can see which one has the massive predatory teeth, shape of nose, and general skull shape that would be expected of a lion. They can also see which two skulls have a greater similarity, with the expectation that these are the gorilla and human. The gorilla skull would be much bigger, with a backward slanting face and bigger, sharper canines. The reader will have little difficulty distinguishing them. At a more refined level, a forensic anthropologist can tell whether the owner of a human skull, when alive, looked more like sub-Saharan Africans, Europeans, or East Asians. If the skull has a blend of traits, they can detect this too. The differences in appearance between people indigenous to Europe, East Asia, and sub-Saharan Africa are due to climatic adaptation. North Africa, West, South, and Southeast Asia are zones where people of different continental appearance have been mixing for at least 3,000 years. Other works by Pomegranate Publishing, such as the Black Summer Trilogy, Racial Unity of the Ancient Egyptians and Nubians, and Black Gods and Civilization of Ancient India, show that the people of the mixing zones approximated sub-Saharan African appearance before 3,000 years ago. The role of climate. Climate influences the shape of the skull and face. We know this because of the many studies that have shown that the shape of these places consistently vary with climate. Because of this, we can examine an ancient skeleton and tell whether it is indigenous to a particular kind of climate. There is a considerable amount of variety within a population. This is why it is ideal to have at least 30 skulls of one sex from a population to see the dominant trend. It is about trends and not absolutes. There are no absolute human populations. In zoology, a race is a subgroup within a species whose defining characteristics are absolute. This is what is meant by "there's no such thing as race," a claim that, if misunderstood, has the potential to cause more confusion than it clears up. It is not intended to prevent us from learning about the physical appearance of skeletal individuals and populations. The variety within populations is something we shall see repeatedly as we go through the different skull features and how climate influences their shape. There are 3 zoological rules which are responsible for much of the geographic variety in physical appearance amongst humans. Allen's rule states that as one moves from warmer to colder climates, they will find the length of limbs decreasing in native races within a warm-blooded species. This predicts longer limbs in tropical and subtropical animals in comparison to their temperate counterparts of the same species. Bergman's rule states that as one moves from warmer to colder climates, they will find the total body size of native races within a warm-blooded species increasing. This predicts smaller animals in tropical and subtropical climates in comparison to their temperate counterparts of the same species. Glauger's rule states that as one moves from colder to warmer climates, they will find an increase in outer covering melanin in native races within a warm-blooded species. This predicts dark-colored outer coverings in tropical and subtropical animals in comparison to their temperate counterparts of the same species. What is a native group? Rules have exceptions, but even they can often be explained by knowledge of other rules or by knowledge of the exceptional population's history. Just because people are located in warm climates, it does not make them warm-adapted. One has to know how long they have been resident in the tropical or subtropical geographic zone. White South Africans, for instance, are of European origin and began arriving in the subtropics just over 3 centuries ago. There has not been enough time for adaptations according to Allen, Bergman, and Glauger's rules. The indigenous people of tropical Central America originally came from the Bering Straits, far to the north. They have made a few adaptations because they have been there for many thousands of years, but their physique still shows clear signs of cold-adapted origins. The peoples of tropical Southeast Asia and Polynesia are, in their physique, also cold-adapted. The original peoples of this region were Negritos and Melanesians, who have warm-adapted physiques and have heavily pigmented skin. This is in keeping with Allen, Bergman, and Glauger. Many Indo-European-speaking ethnic groups in and near subtropical West Asia, such as Persians and Afghans, have ancestors who came from further north over 3,000 years ago. Logically, the Semitic-speaking groups in West Asia were also affected by their presence because of intermarriage. There was also settlement of Indo-European and Hurrian speakers in Syro-Palestine. We need to bear in mind the presence of cold-originating populations in hot climates when we look at the evidence correlating climate with the skeletal structure of present-day populations. What forensic anthropologists say about climate and human physique. Several morphological features such as stature, nose form, body build, head form, etc. are affected by variable climatic stresses. Wenderich, 1945, Hulse, 1971. Climate and Head Form in India, by S. Bharati, S. Som, P. Bharati, T. S. Vasula, in American Journal of Human Biology, 13, 2001, page 626. The strongest findings have linked climate to body weight, body proportions, skin pigmentation, and relative nose and head width. Human Nasal Protrusion, Latitude and Climate by J. M. Carey and M. T. Stigman in AJPA 56, 1981, page 317. On the cold-adapted proportions of native Central Americans. The reference is page 423 through 447. Body Proportions in Late Pleistocene Europe and Modern Human Origins by Trenton W. Holliday in Journal of Human Evolution 32, 1997.